All right, you guys, so this is going to be the finishing up of our types of chemical reactions notes. So far we've already had the 5 general types of reactions. We went through single replacements, we went through double replacements in detail. Now we're going to go through the remaining 3 parts of these notes. So we're going to start with our 3rd type of reaction, which is synthesis. And in words, we have 2 elements combine to make a compound. Okay, that's the simplest kind of synthesis. But we can get more complicated. So also, if 2 simple compounds combine to form a more complicated or a more complex compound. Okay. All right. So again, 2 elements are combining to make one compound, or 2 compounds are combining to make a more complicated compound. But either way, you only get one thing on the right side of the arrow, on our products side. Okay. All right. So let me go for our fake example again. So we have element A plus element X. Let me grab an arrow here. Form together AX. Okay, so element A plus element X makes AX. That would be an example of a synthesis. Okay, again, you're looking for reactions where only one compound is made. Okay, and I'm actually going to change that word compound. Sorry if you're writing with me, to product. Only one product is made. There is only one thing after the arrow. And that thing can be pretty complicated, but there's only one. There's no plus signs at all after the arrow. Then that means you've just synthesized something. Synthesis. Okay, here's a real example. I'll give you a couple. One where we have 2 elements forming a compound, and one where we have 2 compounds forming a more complicated compound. So here's the element example. If you have zinc plus sulfur, you can get zinc sulfide, ZNS. So yes, there are 2 elements on each side. There have to be, okay? You have to have balance. But on the right side of the arrow, they are combined. You have a single compound on the right side of the arrow. Okay? All right, another example, let me just tab over here, space it out, would be if you have NH3. That's a simple compound. And we add it to H2O. Those 2 simple compounds will combine and they will create a substance called ammonium hydroxide. Oops. NH4OH. Okay, so again, only one substance on the right side of the arrow, 2 substances before the arrow. They're combining. There's no plus signs over here, so that is a synthesis reaction. All right, so that's the end of the synthesis piece of these notes. Now we're going to go into the opposite, decomposition. Okay, all right, opposite. It is a compound breaks apart. Whoops. A compound breaks apart into 2 or more simpler substances. A compound breaks apart into 2 or more simpler substances. Again, those simpler substances can be elements or simple compounds. Okay, so bullet points for these ones. Our fake example, we would just flip around what we had up for synthesis, or we can use different letters. By will split apart into B plus Y. Okay, so again, overly simplified there. There actually happened to be 2 elements, B and Y, but I wasn't really going for a real compound. That was just supposed to be fake. Okay, there is only one reactant Okay, so before the arrow, there is only one substance. All it can do is fall apart into different substances. Okay, so that's decomposition. You've probably heard the word decompose before. Like a log laying in the woods decomposes over time. It breaks apart into little pieces, breaks down. Okay, same thing here. BY is breaking apart into B and Y. That is decomposing. It's breaking down. Okay. Here are some real examples. Sorry, I lost my place. Okay, here's one. H2CO3. Okay, so that's a compound. And that's the only thing on the left side of the arrow, that compound. It's going to break apart into H2O and CO2. Okay, so we got H2CO3. That's actually called carbonic acid, and that's what's used to carbonate our beverages. So when you open a soda, you start to see bubbles because this carbon dioxide is being released. That's a new substance. And it leaves behind water. So every time one of these molecules falls apart, we get carbon dioxide coming out as bubbles, and we get some water being released. That's actually literally why when you drink a flat soda, it tastes like it's watered down, because it is. Okay, another example. Some of you might actually have hydrogen peroxide in your bathrooms. We use it on cuts to kill bacteria. Anyway, H2O2 is hydrogen peroxide, and over time it actually expires, and that's because it breaks apart, it decomposes, and it turns into H2O and oxygen gas, O2. Okay, now this one is one of the only examples that I've used that is not balanced right off the bat. So if we wanted to balance it, we would have to fix things a little bit here. I've got 2 oxygens on this side and I have 3 on this side, and my 3 are kind of split up. There's not really a way to make an even number an odd number. So I need to make this side have an even number. So I'm going to double my H2O because that will make an even number of oxygens. So now I have 4 hydrogens on this side, and I have 2 plus 2 is 4 oxygens on this side. So I'm going to put a 2 in front of my hydrogen peroxide to balance. Okay. So anyway, I just wanted to balance it for you so you're not like, what happened to the, or where did that 3rd oxygen come from? Okay. So those are 2 examples of decompositions. And again, it can be even more simple than this if we break something apart into 2 elements. All right, our last type of reaction is combustion. I'm going to go ahead and scroll down here so we can center that information. Okay, combustion. This is burning a fuel in the presence of oxygen. Burning a fuel in the presence of oxygen. Burning a carbon-based fuel. Remember, carbon-based is actually, there's a word for that. We've learned it. It's organic. So anything that has carbon as its base is going to be organic in terms of fuels, okay? Burning a carbon-based or organic fuel always creates carbon dioxide and water. Okay, carbon dioxide and water are always the products. Also, something that we need to know about combustions are they are always exothermic. Now, if you look back in your notes, we took notes on physical and chemical changes. One of the possible signs of chemical change is a transfer of energy. And that can be either releasing energy or absorbing energy. Well, combustions are always releasing energy, and that is exothermic, okay? So, oops. Releasing energy is the definition of exothermic. Okay. I don't really have very many bullets for this one. I'm just going to go through some examples. Okay, and all of them are going to be the same general format. We'd have to balance them afterwards, but here's the general rule. You're going to go fuel, and I'm underlining that because we would never just write fuel in the reaction, plus oxygen, because they all need oxygen in order for the fire to happen, will create CO2 plus H2O. Okay, so fuel plus oxygen creates CO2 plus water. Now, what I'm going to do now is I'm going to go through and I'm going to list some examples of fuels. Okay, so CH4 can be a fuel. That's methane. Okay. Just going to go with what I have. C6H12O6. Oops. Hopefully you recognize that one from biology, but that's glucose. This is what we burn in our bodies. And we say we burn calories. We do. We combine our sugars with oxygen. We breathe in the oxygen, we swallow the sugar, and our body uses both of those things to create carbon dioxide and water. When we breathe out, we are releasing that carbon dioxide and that water. So we are living, walking combustion reactions. Oh, I'm running out of space. Okay. This skipped to another page here, but hopefully you're still on the same page. We've got C8H18. Whoops. The reason I chose that one is it's a main component of gasoline. It's octane. Okay. Another one, whoops, that we're pretty familiar with is C3H8. That's propane. So most of us know propane is a fuel. We use it in our camp stoves. Some of us use it maybe, let's see, when you use a turkey fryer, you might use propane. Food trucks use propane. So propane is a pretty common, generators, a lot of generators use propane. So anyway, that's a pretty common fuel. But it doesn't matter which of these things, or there's plenty of other ones, carbon-based fuels, that would be inserted right here. You add oxygen to it, it's going to make CO2 and water. You might need a little bit of an activation energy, like when you strike a match, okay, just to get it going. But once it's going, it will burn, okay? So those are the notes for our types of reactions. Make sure that you get all of those done and submitted into Canvas, and we will see you in class.